Hi everybody, this is Mrs. Peachy from your WCA Earth Science class, and I'm doing a video tutorial here for your portfolio on Geologic Age Lab. So this is from Unit 2, Lesson 13. So for this is your very first portfolio for this class, and for this portfolio you will need to have a box with a lid. It says a shoebox. I use a slightly different size box here, but it's a box with a lid. And you need to have 100 cubes of some kind. Now, in the directions or in the list of materials that I sent you, it mentioned sugar cubes, because you can buy a box of sugar cubes and have plenty of those. I guess it doesn't really matter what kind of cube you use so long as you have 100 of them. So I have these little foam cubes that are actually for math. I was able to get they're base 10 cubes. You can get them for math pretty cheap. And what you're going to be doing for these is there are 6 sides to a cube. So you're going to actually be marking just one of the 6 sides. I put an X on it. Just one of the 6 sides is marked. The other ones are unmarked, okay? And all 100 cubes goes in your box with the lid, and you'll put the cover on the box with the lid. Now, for this portfolio, you're going to be looking at something called absolute age. Absolute age is precisely or exactly how old something is, right? An analogy that I have is that maybe your absolute age is 15 years, or 14 years, or 16 years, or something like that. It's not exactly how old you are to the hours, minutes, and seconds, right? But it's your age. That's absolute. Your relative age might compare your age to something else of known age. So maybe we don't know how old you are, but we know that you are about as old as the iPhone. That's about how old you are. You've been around as long as the iPhone. Or maybe you're about as old as let's see. You're about as old as like I say a smartphone. I'm thinking of something else that would have been about that same time frame, but you guys probably know better than I do what was around in that time frame. But that's a relative age. I'm not telling you how old you are in years, in units of time, but I'm comparing your age to something else that I know how old it is. So I'm kind of giving a relative age. You're younger than 9/11, but you're older than the 2012, when they're worried about the end of the world in 2012. You're older than that. So it's somewhere in that frame. So it kind of gives you a relative, an approximate age. So that's what this unit actually talks about. I'm going to click here on my lesson viewer, on the actual lesson, and this brings me to something called the Vega Viewer, it says, and this is just how you view your lessons for this class. A little bit different. This is the new way that they'll be doing lessons in the future. So this one talks about, relative versus absolute age, right? It also mentions that you need to have your shoebox, the lid, for this. Your cubes, which I have those foam cubes, and a permanent marker. And you're going to be using it to model this absolute age, measuring the absolute age using something called half-life. Half-life actually is the amount of time it takes for half of the radioactive elements in something to change into something else. So some substances have radioactive elements in them. That means that their nucleuses are unstable. Nuclei have protons and neutrons in them, and usually that's a pretty stable thing. But in a radioactive element, the protons and neutrons want to leave the nucleus, and that changes what that atom actually is. In this example, we see uranium is actually changing into lead. And after a certain amount of time, half of the uranium changes into lead. So once half of it is changed, that's what's called the half-life, the amount of time it takes for half of it to change. In this case, for uranium changing into lead, the half-life is about 4.5 billion years. So it takes that amount of time for 1/2 of the uranium to change to lead. So if I start off with 2 kilograms of uranium, after 4.5 billion years, I'll have 1 kilogram of uranium and 1 kilogram of lead. So that's what that means. And then another 4.5 billion years later, I'll have, 1/2 kilogram of uranium remaining, and I'll have the rest of it, I'll have, 1/2 left, and the 1 and 1/2 will be lead, right? The rest, the 3/4 that's remaining, will be lead. Alright, so let's go to the lab activity. Now, here's a little change from what's actually in here. It does tell you to click on the Geologic Age Lab Report, and that brings up a PDF file. Problem is that we have some troubles in Connexus with you guys saving these in a way that makes sure that I get all your information. Oftentimes what happens is when students use this, these are nice documents that you can just click and type into. They don't save properly, and then all your data gets lost and you have to start over. To avoid that, I would highly recommend you going to my website. Now, the website that I have is linked in my message board. So you can go to my message boards and you'll find a link to my website. Once you get to my website here, just if I can move my picture out of the way, there we go. You can go to the Earth Science A box at the top of the screen, and then you'll see that there's a Word version, Microsoft Word version of this lab. And you can click on that, and it brings it up actually in Google Docs. But you can hit the download, and you can download it into Word, which is nice because, it's not as pretty as the PDF, but you can definitely save it and submit it as a document much easier and make sure you don't lose any of your data, okay? So what you're going to be doing for this, like I said, is you're going to take your box, and I'm going to go ahead and give me just full screen video for a minute. One second. Okay, so you can take your box here. Again, I actually labeled mine on the end here, just so I don't lose it. But inside of it, again, are your 100 cubes with one side labeled with an X, right? The rest of it's not labeled. So the first time, it takes a little bit of time here to do this because you're going to, it says turn over the box twice. So 1, 2. And actually, I'm going to kind of shake it out just to make sure that I have everything in here correct. And then if I can bring the camera down to my box here, kind of see what's going on. You can see this very well because I have a bunch of stuff in the way. Okay. You're going to take any cubes that have the X showing and remove those from the box. 1, 2. Some of them got stuck kind of behind this flap, so I'm going to pull those out. I have one behind the flap with the X up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That one was showing, I just didn't quite catch it. 14, 15, 16. No, it's not. 17, 18, 19, 20. Those guys out of there, and 21, 22. So I have 22 cubes that get removed from the box. And if I go to here, you'll see for trial 1, I can put down there 22 that got removed. So that means I have 78 remaining. So remember that we have 100 total. And then I'm going to do this again. I'm going to put the lid back on. And I'm going to shake it again 2 times. 1, 2. And I'm going to open the lid up and I'm going to take out the number that have the X on it. And I'm going to continue to do this until I run out of cubes. Okay? Okay, so we'll continue to do that until we run out. And then once we're done with that, we're going to actually have you graph your data. So I'm going to go ahead and just make up some fake numbers here so that we can do the graphing together. So I'm not going to go ahead and do all the shaking for you here today, but I can at least help you with the graphing. Okay, so you can see that this is my data. And again, I just made this all up here, so make sure you get your own data. According to my data table, though, I didn't ever get down to 0 cubes. I ran out of space. So if you get to 12 trials and you're still not at 0, then you can stop at 12 trials, okay? So then it does ask you to do this a second time, to do a total of 2 sets of data. Now this is important because using the scientific method, if you think about the scientific method, one of the steps is to make sure you repeat your data. Repeat your experiment to get another set of data, at least a couple times usually. But we're just doing the 2. But this is important, so it kind of takes out that random chance factor. The more times you repeat it and come up with similar results, the more times the more credible, the more reliable your information. So again, I'm going to put some fake data into data table 2 and we can kind of see how that's going to work with the graphing process. So now we have some fake data in data table 2 as well, just to kind of give us some stuff to graph. And we'll go ahead and make graphs of this information, okay? So I'm going to have you do a graph here in Microsoft Word. So I want you to be able to do this so the graph is inserted right in your lab report. Okay, so first of all, I'm just going to go to the top of my screen and I'm going to go to the Insert tab, Insert Chart. And when we do this, I want the line graph option, and I'm going to click on that first line with markers because that gives me the little dot so I can definitely see where my data points are, and I'm going to double click on that, okay? And that's going to bring up a couple of different things. It's going to bring up a little Excel window and it's also going to bring up a graph. Now we want 2 lines on this graph. You're going to have your trial 1 graphed and trial 2 graphed, and you will not have that 3rd line. So I'm going to get rid of series 3 right away. I'm going to go ahead and just click on column D and hit delete and get rid of that. So I'm only doing columns 1 and 2. So what I'm going to do here is I want this to be the number remaining, okay? I'm going to go ahead and just delete the categories. Okay, take that back. I'm actually going to call this column shake number. Okay. And then this is going to be number remaining, trial 1, right? So I'm just going to call this trial 1 for now and trial 2. And then we'll go ahead and we'll label these down through, whoops. Do this. I'm going to go ahead and delete the data out of these guys too. Just that's not okay. It's being kind of yeah, we're going to go ahead and just keep adding these guys in here. I didn't like before that I had data in the other columns I wasn't using, so. Okay, there's 12 trials, right? So then let's go back to our first set of data. Remember, this is numbers remaining. So trial 1, we're going to go ahead and put 78, trial 2, 65, trial 3, 54. We're just going to enter in the numbers from this column here, okay? I'm going to go ahead and pause this while I enter in the rest of the data. So you can see that I finished entering the data here for trial 1, and then it graphed this really nice inverse curve here on the graph, okay? So we're going to do the same thing then for trial 2. We're going to go ahead and put the numbers into the Excel worksheet from trial 2, number of cubes remaining. I'm going to go ahead and do that real quick. So now you can see I put all the data in for trial 2, and I have another really closely mirroring line here, okay? Yours might not be like exactly that way because, again, I kind of made up my data. So then I'm going to go ahead and change some attributes from this chart. I don't need the data table anymore, so I'm just going to X out of it. I don't need to have that there. But on the chart, I want to give it a title. I'm going to call this number of cubes remaining. And then I can go ahead and I can change some of the attributes here by, like, I can label the columns and stuff just by clicking on them. So if I click on this column, actually what I'm going to do is, I'll show you the top here. Under design, I'm going to actually go to all the way over to the left where it says add chart element. I'm going to click on that, and I want to label the axes. So axis titles. I want the primary vertical axes, which I'm going to label. I'm just going to type it right in place, and I'm going to call this one number of dice. Or not number of dice, number of cubes. And then I'm going to go add chart element, axes titles, and do the primary horizontal. And I'm going to call this one number of shakes. Okay? So then that gives me, there we go, number of shakes. I'm sorry about that. That's where I typed that in a second ago. So that gives me a data table that is now embedded directly into my Word document. It's really nice in there. You don't have to have it in a separate document or anything like that. It's already part of your document. Okay. Now going down, now you're at the data analysis. The first question is, what's the half-life of the element lokium? Well, remember, half-life is when you have half of your original number remaining. You're going to look at your original number was 100, so we want to determine when half is remaining. We're going to go and say, okay, how many shakes when 50 were remaining? Okay. I'm going to show you one more thing on this graph. I'm going to double click on here, and I'm going to go to the top under design, and I'm just going to switch and change it to this one here, the second one, because I like having my grid lines on there, and that first one didn't give me all my grid lines, so I'm just changing that for now, okay? Alright, that allows me to see this a little bit better, because when you're looking at the number remaining, or excuse me, the number of shakes when 50 of them are remaining, I can follow my 50, this line, over to the graph, my curve, follow it down, and I can say that the half-life according to my graph is 3.5 shakes. That makes sense? So when 50 cubes remain, if you follow it over to your curve, wherever it intersects the curve, follow it down to your x-axis. And that tells you the half-life. So according to mine, which yours is different, remember, because I made up all my numbers. According to mine, this would be 50, the half-life is 3.5 shakes. Okay. So it says, after which trial did you reach the half-life of lokium for each test? That occurred, well, we just said 3.5 shakes, so it was after the 4th shake, right? Because obviously I didn't do 3.5 shakes. I'm going to color, I like to make sure you guys that the answers are a different color. So if you can color them, that's awesome. Highlighting them is like the best, because then it helps me. How do the graphs compare? How are they alike? They look very similar, don't they? My graphs, at least, parallel each other the whole way down. Again, yours might be different. Alright. And then what would you expect a third test to look like? Well, what do you think? So now, having just studied the data and pattern of trends, you should now be able to draw some conclusions about knowing the half-life of the element lokium. It would help you determine the absolute age at which this element is found. In a paragraph, create an imaginary example of finding a given amount of lokium and DOL in a rock, and then determine the absolute age of that rock. So now what you're assuming is that every trial is 1,000 years. So if I shake it once, it's 1,000 years. If I shake it twice, it's 1,000 years. Or 2,000 years, excuse me. Shake it 3 times, that's 3,000 years. So then 3.5 shakes was 3,500 years, right? So they're basically saying here, and this is kind of a tricky one, and I'm going to do this example, but you have to do a different one, okay? So, if I have 50% lokium and 50% DOL, then my rock is 3,500 years old. Okay. What happens if you have, you guys could answer these questions. How old is the rock if you have 60% lokium and 40% DOL? Remember, in this case, DOL is kind of like lead for our uranium example. It's what lokium is turning into. Then your rock is how many years old? You guys can answer that question. So using the graph, the first one, for example, I could do this. I could be like, okay, I have 50% here. This is the number of cubes remaining. So this is my logium. It tells me the half-life. If I have 60% remaining, you have a different number when you intersect the x-axis, right? So 60% intersecting would give me 2,500 years. So if I had, so in this case, it would be 2,500 years old. Does that make sense? If I have 60%. So now, those are two examples that I did. Do a different one. You could do 70% logium or 20% logium. It doesn't really matter which one you do. Whichever one you're doing, you're basically just, because we started with 100, this is already in percent. So if you had 20%, you're just going to follow it over till it intersects and follow it down to get the age. Does that make sense? So come up with an example, situation, and then use the graph to help you determine the age of the sample at that time. So hopefully that part makes sense too. That's probably the trickiest part of this whole lab. Alright, so don't forget to save this, right? Make sure your name's on it too. Don't forget to save it. Once you save your portfolio, you actually submit it in the next lesson. So you don't submit it till the lesson 14. And then you click on Geologic Age Submission. And then you can upload your files here. Okay.
And then you're going to go to virtual classrooms as the next tab.
No, I can't do this right now because it won't let you do this unless you've completed every single lesson prior, and since I haven't completed every single lesson prior, like checked them off on my own lesson viewer, I can't actually submit it. But you will have this open. As long as you have completed everything else prior, this will be open and you'll be able to upload your Dropbox item here. It's a little different looking than you're used to before. Okay? So hopefully that all makes sense, ladies and gentlemen, and that's your first portfolio in Earth Science. If you have any questions or concerns, you can feel free to give me a call. I'm at extension 2204, or you can send me a webmail message. Have a great day.